Sorry about that. My name is Ben, and I work at GitHub. And I work in the ops group at GitHub. And my timer didn't start, so sorry about that. I work in the ops group, and specifically I work on supporting and maintaining and building infrastructure for our internal applications. You may have heard other Hubbers talking about things like Team, which is our internal kind of Twitter-type social networking site, or we have a thing called Hire, where we track candidates and interviews, and we have a whole bunch of those. We have about 150 applications that we use internally. They're not all web apps. Some of them are utilities and services that enable other things, but there's a lot of them, and my team supports all of them. Most of the internal tools infrastructure is on EC2. In fact, all of it is on EC2. Either directly VMs that we own or via Heroku. And that's what I want to talk to you about today. I personally, just as a technologist, I really love the cloud. I think it's a super cool concept. I actually know what it means. I don't use it as a marketing term. And I think it's awesome. I really like the idea that I can just say, hey, I need 25 cores right now for 10 minutes and get them and then throw them away and be done with it. I love that. I love the elasticity and the on-demand nature of compute resources. And it's just super cool. It's really exciting to me. Our use of AWS and Heroku at GitHub isn't really anything special. Almost everything that we do is stuff that we've heard other people doing and copied. We take some notes from Netflix. They're a huge AWS user. A lot of our ops team came from Heroku, and so they know the right ways to interact with Heroku. So none of it, I don't think any of it is groundbreaking, but I still think that there's a lot of stuff in there that's kind of cool and a little bit different, and that's kind of what I wanted to share with you today. My hope is that by the end of this, you'll be able to come up to me and tell me what I'm doing wrong, what things we can do better, and where we can improve. And then maybe also at the end of it, go and build some of the things that we haven't gotten to yet, and then open source them so I don't have to build them. I'm going to be talking about chat ops a little bit. If you haven't heard this term before, it's how we refer to our way of working. GitHub is a little bit more than 60% distributed, meaning not in San Francisco. In fact, nobody from the ops group is in San Francisco at all. If you look at the ops group, I think there's 16 or 17 of us, and the largest concentration of ops people in a single city is 3. There's no city that has more than 3 ops people in it. And so, whereas GitHub is very focused on using chat, and Campfire is what we use, as our primary method of communication, the ops team tries to use it as our primary method of work as well. And that means automating all of our common tasks, common operational tasks, through Qbot. And I'll show you some examples later, but if you want to get a really good background on this, go look up Jesse Newland's talk from RubyFusa last year, 2013. It's on YouTube. It's a great talk and a really good introduction to the concept of chat ops in the context of our ops team. For a sense of scale, I'd like to kind of give you an idea of what our infrastructure looks like. The numbers here are deliberately vague, and I apologize for that, but I've been told that I can't tell you real numbers. So, we have a data center. It is in the middle of nowhere in Virginia, which has some advantages that I'll get to in a second. We have some number of hundreds of machines there. It's more than a few hundred and less than 1,000. They're mostly Dells. They're mostly C-Series, high-density sled servers. If you're a hardware nerd like I am, come find me later and I'll tell you all about them because I think the C-Series chassis are super cool. The data center powers pretty much all of GitHub Dot Com. When you go to the website, most of what you're seeing is being served out of the data center. There's a few systems here and there that are on EC2, but not many. Interestingly, we do almost no virtualization in the data center. What we do is in service of our continuous integration systems and some of our build systems, and no virtualization is at any point involved in the serving of .com, which kind of surprises me every time I think about it, but that's what we do. one of the advantages of being in the middle of nowhere in Virginia is that we are figuratively right next door to the US East 1 region of AWS, which is kind of cool because it means our latency is a function of the speed of light. I mean, I guess it always is, but like we're very, very close to US East 1. And I'll talk about in a few minutes why that is as cool as, well, cool enough to justify how excited I am about it. Anyway, we have instances and resources in 5 regions of AWS. They're primarily in US East 1, but we also have stuff in Europe, in US West, and a couple in the APAC region. A little over 300 EC2 instances in total, a little over 40 RDS instances, 250 terabytes of EBS across a little more than 400 volumes. We've got over 100 S3 buckets, which will be relevant in a minute. And then we also use CloudFront, DynamoDB, SQS, SNS, SES, Elastic MapReduce, Elasticache, and a whole bunch of other AWS services in small ways. We additionally have 150 plus applications running on Heroku. I don't know the exact number, but it's more than 150. To be fair, a lot of those are staging instances or experiments, but they're all things that actually take up my time and energy. About 230 dynos total running those applications, so obviously a lot of them are single dyno apps, but some of them are actually scaled up for real use. More than 50 Heroku Postgres instances and 200 and what, I actually have an exact number for this one, 264 instances of 25 different add-ons. So we use Heroku pretty seriously. We also have a handful of servers in other places. We've got some physical hardware that we've leased sitting in other people's data centers. We have some VMs that we've leased from other cloud providers. Most of this stuff is pretty uninteresting with the possible exception of the enterprise team's build system, which is a 3-node ESX cluster that runs a few hundred VMs that are the enterprise build product. It's really cool, but I don't know much about it, so I can't tell you about it. It's probably far more interesting than what I'm about to tell you. So if you ever get to talk to the enterprise guys at GitHub, press them about it, because it's really cool. So AWS. Early on in our use of AWS, it was meant almost specifically to supplement our physical infrastructure. The idea was that if we had a burst of traffic or queues got really backed up or something like that, we'd be able to just just rub some cloud on it and make those things go away. And it works pretty well for that, it turns out. It's sort of, in some ways, what EC2 was originally designed for. At some point, though, we started moving faster than we could procure hardware. And we got to the point where we needed to deploy new applications, but we didn't have hardware for it, and so we'd throw it on EC2, which meant that we ended up having more permanent things living on EC2 than we had maybe originally intended, and certainly more than we had built tooling for. These days, most of what's running on EC2 are things that were prototyped and built before we had hardware, and so they're just waiting to move onto real hardware once it's available. Things that actually require elasticity, so data processing, our analytics team has a large cluster of compute servers in EC2, and that's probably going to stay there forever because it just makes more sense. And then apps that, for various reasons, mostly technical but sometimes not, don't work very well on Heroku. That's almost everything that we've got on AWS. One of the things that has been really challenging for us is AWS's resource limits. And wow, that font is small. So when you create a new AWS account, one of the things that you're going to be faced with is not being able to start more than 115 EC2 instances, which seems like a lot, but it isn't. Or 40 RDS databases, again, seems like a lot, but that stuff runs out pretty fast. These are the limits that we've actually already hit. We have way more EC2 instances than that. We have more reservations, more RDS instances, a lot more EBS storage. Excuse me. And IAM, which I'll talk about a little bit later, we're on those limits as well. But there's one that really, really hurts the worst, and it's S3. The reason is that this is the only limit on AWS that you can't have raised. Everything else you can file a ticket, and if you can justify it, they'll turn it up for you, and you can run more servers, whatever else. You cannot, under any circumstances, get more S3 buckets. I'm sorry, I need water. I'm just going to take one of these. I apologize. I've been sick for a week, and I'm amazed that I'm not coughing more than I am. So sorry. Anyhow, early in our growth, we made some bad decisions. And one of those bad decisions was creating separate S3 buckets for every application. Excuse me. And in some cases, every application and every environment, so production, development, and staging, would have separate S3 buckets, which means you run out really fast. You run 30 applications and you're out, and we run 150. So we need to find out ways to deal with this. And probably the thing that we do on AWS that I think is the coolest is using IAM, which is the Identity and Access Management Service, which doesn't sound particularly exciting, but I think it lets you do some really cool stuff. It's effectively, it's LDAP. It's a glorified user manager. But what it does is it allows you to create a set of credentials that has access to a specific subset of resources on AWS. And what that let us do was consolidate those buckets down and say that each application gets one bucket, and the development, production, and staging sections are prefixes in that bucket, and each one of them has a set of credentials that can only read and write from that prefix. This has helped a lot. It reduced our bucket load by a factor of 3. Where we've used it, we haven't universally rolled this out, but it opened us up to do some even cooler things. Excuse me. One of the concepts in IAM is that of a role. A role is not a user, but it is just an entity that you can attach policies to. And then users or other resources, like EC2 instances, for instance, can assume that role and gain the rights that it has. So in a way, this is kind of like pseudo mode for AWS. Like, I can say, I require for 20 minutes credentials that can access a certain bucket. And I go to STS, which is the security token service, and request to assume that role. And assuming I have permission to do so, I get credentials that let me go out and do whatever it is that role can do. Where that starts to get super cool is when you mix it with instance profiles, which is a way that you can attach a role permanently to an EC2 instance. So when you launch an instance, it can have one of these IAM roles attached to it. And what happens is that the credentials are put in the instance metadata. So your app doesn't have it. You just go fetch it out of the metadata. Those credentials are automatically rolled. Last time I checked, it's every 75 minutes-ish. So like every 75 minutes, you're getting a fresh set of credentials. And you can just read them, and you can do whatever. So that might be a little bit confusing. The way that it all fits together is this. You have an S3 bucket, your app, and you have prefixes within it for each environment. Then you have IAM roles that match each environment, your app production, your app staging, your app dev. Then when you create this instance down here, the staging instance, you apply the staging IAM role to it, and then it has credentials on the machine. You didn't have to put it in your application, they're just there, that has access only to the staging prefix in that bucket. You can attach a whole bunch of other policies. In fact, maybe every single thing, every single action you can take on AWS can be limited by these policies. This is just the one that we use the most of, and we're looking to roll out a lot more as we go along. The other kind of related thing is cross-account management, access controls. This allows you to have two accounts and say, this account can access resources in this account. So if you absolutely have to have more than 100 buckets, you just create a new account and start putting buckets over there, and then write policies that allow resources in this account to access buckets over here. The way we use that is to create secure write-only drop boxes. So we have our sort of like main account, but they need to ship data off to somewhere else, usually for like database backups or things like that. And so they have credentials that can only write to a bucket in another account. They can't read the data back, they can only write to it. And that is super handy for us. I talked a little bit about chat ops earlier, and I think some examples would be good. So the question is, like, how do we chat ops EC2? This is a terribly tiny screenshot, and I apologize for that. But we have this thing called Cloud AWS. You just say /Cloud AWS in chat, and you get tons of different things. One of the things you can do is list all of the instances. This is like, I don't know, 10-ish out of the 250 that this is returning right now. And there's a whole bunch of stuff off that edge of the screen too about their security groups, their IAM roles, and all this other stuff. So it's kind of instant access to all of our EC2 instances. You can also, I apparently took the slide out, where you can filter it down to say, I only want to see, this is Alembic, which is one of our subsystems. I only want to see the Alembic hosts. You can also provision a server, which is what I'm doing here. I said, create me a server called temp Bleything 2 and have it be an M3 medium. And then it took, 1,345 seconds to do it. But then I got all this information back with the IP addresses and everything else, so I just have a server ready to go. One of the cool things that happened here behind the scenes is that it automatically created an app and environment pair security group and IAM role. And so that role, because you can only create those roles, both security groups and IAM roles can only be assigned to instances at launch time. We automatically create them if they didn't already exist and assign them to the application or to the instance when we provision the instance, so that if we decide we want to use that later, we can just go write policies into it rather than having to re-provision the instance to add those features. And then, of course, you can delete instances too. This magic word thing is are you sure you meant this? It changes every day. This one, I don't know why I blanked it out. This one was apples. So, yeah. So this is me being nerdy again. Just as I got excited about user management, I get excited about cost management. So there's a resource tagging feature in EC2 or in AWS that was originally designed to help you group resource usage together. So you say you can add arbitrary key value pairs to almost any resource in AWS. And so we do things like the app, which is the first part of the host name, in this case ops, the environment staging, the provisioner. This one was provisioned by me in Campfire using Cloud AWS, or the role, which is the second part of the host name. And what this allows us to do is say, show me every resource in AWS that is being used by the ops application, or being used by the hire application, or whatever else. If you're really diligent and you can apply these tags to every object in S3, you can apply them to buckets, you can apply them to IAM users, you can put them on RDS instances, you can put them all over the place. So it really helps you to kind of keep that stuff together and to be able to query for specific subsets of your infrastructure. This is mostly used for cost management, which is not really in the scope of this talk, but I like it, so I'm going to talk about it anyway, and you can't stop me. So it used to be that, this is a pie chart. It used to be that this is how much money you spent on EC2. You just get a bill, and you paid it, and your stuff stayed on. And that gets kind of annoying when you have 300 applications running. So we built this thing that uses our graphite and polls EC2 to say, this is how many instances we're running of each type, and to estimate approximately what they're costing. I took off the scale, but the top of this is a very large number. And this is our projected annual spending if we don't shut down or add any instances before the end of the year. And The goal of this graph was originally to show that it trends downward over time, which fortunately this one is doing. But it's not particularly accurate. And so if you really want to get a handle on this stuff, there's a couple of different options. I can't show you screenshots of any of them because it was too hard to like blank out the details. But AWS has their own billing reports system that you can use. It's just up in the upper right. It's the drop down that's just to the left of the region picker. And there's a billing and cost management section in there. Then Netflix has an open source tool called ICE, which is really, really, really powerful, but really, really hard to get running and hard to use. But if you have a complex infrastructure on EC2 or on Amazon at all, ICE is a really good way to keep track of how much you're spending on it. And then there's a service that you can pay for called Cloudability, who they're a Rails shop in Portland, and their product allows you to analyze your usage based on those tags, and they also have a feature that will suggest how to optimize your reserved instance purchases to get your cost down. Excuse me. Okay, so enough babbling about costs. VPC is my third favorite feature of AWS. This is a feature that allows you to create a private network in private network space and have it be isolated from the rest of EC2. So, and more importantly, from the rest of the internet. You can put like VPC allows you to put a NAT gateway or ELBs at the edge so that you can route traffic into the VPC if you want to. But it also allows you to connect it to your data center over a VPN, which is what we do, using another thing that I really like, which is called Direct Connect. Direct Connect, I think, is one of those sort of secrets of EC2 that I don't think, or of AWS, that I don't think a lot of people are aware of. And that is, if you're near one of their data centers, you can just plug into AWS. Like, we literally have a cable that leaves our data center and goes to AWS. And it's very, very fast. And you don't pay bandwidth over that link. So AWS's pricing model, generally speaking, is based in part on how much bandwidth goes in and out of those services. With Direct Connect, you don't pay that. And so we don't pay for transfer in and out of S3. We only pay for storage. That's really cool. But the super awesome thing for us is that it gives us a direct connection to our VPCs, which effectively means that we have EC2 in our data center. The latency is as though it was just down the hall, because it is effectively just down the hall. But we have all the elasticity that you have of EC2, but in our private network space and isolated from the rest of their network. Direct Connect is super, super cool. So we also use Heroku, as I mentioned. And I have to apologize that I don't have a lot of details on Heroku. I kind of got shut down at the last second on some of the stuff I wanted to share, and then also ran out of time. But we love Heroku. We think it's awesome. Like I said, a lot of our ops group came from Heroku, and we've got a lot of people who got their start, a lot of engineers at GitHub got their start as consultants or working at startups who worked on Heroku, and pretty much everyone has really fond memories of it. It's way cheaper than running stuff on EC2. Unless you get up to the really, really big databases and huge dyno counts, it is massively, massively cheaper to run applications on Heroku than it is to create instances on EC2. The operational overhead is way lower as well, and this is a huge win for me personally, managing all these applications. If I had to manage 3 to 5 servers for each of 150 applications, I would quit my job. But I don't have to because it's on Heroku. Someone else gets paid to do that. Their support is awesome. You can just email Heroku support and they'll get on it. It's not all great, of course. One of the big problems we face with Heroku is that when there's an outage, we can't necessarily fix it directly. Most of the time, those outages are with add-on providers and not with Heroku themselves. Heroku's platform is generally incredibly stable. But a lot of the times, the add-on providers will not be so stable. And a lot of our internal applications, because they're just meant for internal use, they're not built with production-level resiliency. And so if Elasticsearch goes down, the whole thing stops working. And Elasticsearch, for us, goes down a lot. So that's one of the big problems we have. One of the big upsides, though, is that because Heroku's interface is all command line and Git push driven, Git is something we understand really well. Command lines are something we understand really well. It's super easy to chat ops Heroku, and so we've done it. So if you want to create an application, in chat, you just say Heroku create, and whatever the name is. This Heroku SSL thing is stupid, and it's going away, so ignore it. The way it is right now is that we don't set up DNS or the SSL endpoint when you create an application. You have to issue a second command. What we realized after we built this was that you literally do this every single time you do this, and so there's no point in having them be separate. It's like, I don't have that much time. You can look at your logs. This also has a way that you can effectively grep this. You say Heroku logs, the app name, and then a pipe and the pattern that you're looking for, and it will basically just grep through this and only return matching lines. You can Heroku PS all day long. You can get this. You can scale up and down your dyno counts, and then you can also scale it to 0 if you want, and then I guess you can't delete Heroku apps through this yet, because that's one of those things where we don't allow decommissioning of physical servers in the data center. We do allow decommissioning of EC2 instances, but only because there's no critical infrastructure that runs there right now. But we don't allow, through chat anyway, decommissioning of Heroku apps, which is a deliberate choice. And then you can run commands like break. The thing about Heroku, though, is that they're Postgres, and we are a MySQL shop. And this is not super handy. There are MySQL add-ons for Heroku. I have not had good luck with any of them. So the policy that we have is that the developers are largely responsible for their own database. And so if you're running on Heroku and you're comfortable with Postgres, feel free to use it. I personally am a Postgres guy. I am happy to support my developers using Postgres all day long. But because as an organization, all of our expertise is in MySQL, a lot of developers want to stick with that. So what we tend to do in those cases is we tend to put them on RDS rather than using the add-on providers, because we have a lot of tooling around RDS already because we use it elsewhere. All the cloud AWS stuff I was showing you earlier, everything you can do for an EC2 instance, you can also do for an RDS instance. So we have tooling around that, and it just didn't make a lot of sense for us to invest in building another set of tools for add-ons when we could just use RDS, except that it's quite a bit more expensive. But we do that. So I'm out of time. That was a briefer overview than I intended, but I hope that it was a little bit interesting. And thanks for your time.